Okay, we meet again in our second session. Okay, berjumpa balik kita in our second session of today is Monday, 28th of March. Okay, we are now about apa ni 11:50 AM. Still 11 pagi. So good morning, lagi. Second good morning to our second session. So before kita continue with the example, any questions so far berkaitan example 1 ataupun example number 2 that we like to you like to nak tanya apa-apa berkaitan example 1 ataupun example number 2? Anyone? No question? Tak ada soalan? Okay. Kalau tak ada, then kita continue lah. We continue with our example. Okay, this is the continuation of the example. We have obtained the reinforcement tadi earlier. Okay, based on the bending moment. Remember our bending moment diagram, mana dia? Based on this bending moment and based on the value of 26 kilonewton meter per meter width, we ended up with a reinforcement of H10 at 150 center to center. Satu pula saya. Yeah. And moving on from here, the next stage is the shear checking. Obtain what would be the vertical shear on the left hand support and on the right hand support. Okay. And we remember on the left hand support, there is a negative bending moment of approximately 26. So this would be the free body diagram for the staircase. Dan daripada situ, this would be the two values of shear, kilonewton per meter along the support. Yeah? And we have a value of maximum of about 38. Now we need to check this 38 with, compare this with our VRDC ataupun V minimum. We have two resistance. Shear resistance ada dua. Halangan Ricci, there is two shear resistance. One is evaluated based on VRDC, the shear resistance without any shear reinforcement. Dan yang kedua is the Vmin, the minimum shear resistance. So these two values ambil yang terbesar. So we have these two values, VRDC dengan Vmin. So we select VRDC as our shear resistance, dan daripada situ clearly the design shear not exceeding the shear resistance. So it's okay. Yeah? So usually shear tak ada masalah sangat. The only problem is in terms of deflection saja. Yeah? So for deflection purposes, maka this is something that you've been doing masa RC1 dulu. Check the shear, the reinforcement ratio and comparing that with the apa orang kata ni, reinforce the ratio yang control, rho 0. Okay, rho dengan rho 0. Okay, so from here we can choose which equation to use, and from here in this example, rho is less than kita punya control reinforcement ratio, and from here kita dapatlah kita punya allowable, which is approximately 34, actual about 33. So deflection okay lagi lah, even though I would prefer a much bigger margin between the actual and allowable, and we can achieve a bigger margin of difference between the actual and allowable by slightly increasing from 160 kepada 175 mm thickness, overall thickness. Yeah? And finally kita come to the cracking punya zone, because the H is less than thickness, overall is less than 200, maka the maximum allowable spacing of reinforcement is 3 times H, okay, which is 480 mm. H is 160 times 3, ataupun 400 mm, whichever is less. So therefore kita menggunakan 400 mm. Our actual spacing is 150. So our spacing of 150 is less than 400. Okay. And for secondary is 3.5 H, 560. Comparekan dengan 450. Take the lesser of these two values, maka 450. Maka bar spacing is taken as 400 mm, still okay. So bermakna the spacing of reinforcement, the main bar yang hijau ni, and the blue bar, which is the secondary bar, complies with the maximum allowable. It does not exceed the maximum allowable spacing. Right? So finally kita dapat ni lah. Cuma remember, we still need a top reinforcement over on the left hand support di sini. Okay? There's still a top reinforcement di sini. Alright, any question? What we can see is that in any RC component design, the bigger the span, the component becomes thicker, lebih tebal. Okay? The same applies kepada beam. Okay? The bigger the span of the beam, maka lebih tebal beam tersebut. The same applies juga pada slab, and the same applies kepada staircase. Okay, so we look at example number 1 where the span is approximately 2 point something meters, 2.8, and we have a second example where the span is now has been increased to 4 point something meters. Okay, therefore the thickness between the example 1 dengan example 2 ni berbeza. Sorry. Clearly, the bigger the span, we will end up with a thicker punya component. Okay, so this gives an overview of the staircase design. Example 1 dengan example 2. A more common punya between these two example, yang lebih common, lebih umum is sebenarnya example number 2 lah. Example 2 is a more common problem that you will be facing when you are designing a staircase. Okay. Remember the same principle applies kalau lah, I think we've covered that some dalam last week. If we were to have katakan a case where we have a staircase, okay, staircase in the horizontal component, kemudian we have an inclined section, we have another horizontal section, followed by another inclined section, and mungkin a short case macam ni, right? And the staircase can be designed as in example number 2, sama je. Cuma we have to be aware di mana penyokong support for the staircase. If the staircase support dia ada one support over here and another support di sini, then if only 2 support yang ditunjukkan, only 2 supports, then this would be our span from somewhere center of this support sehinggalah pada center of this support. Right hand support to left hand support, and this would be our overall span L. And this can be represented sebagai mana dia? Okay, as a beam. Okay, as a beam, continuous beam. Kita nampak sini is continuous on the left hand side, and this can be represented as support di sini. We have one support over here and another support di sini. Okay. And clearly the bending moment will now be something yang macam ni. And the loading yang kita akan deal with would be undo dulu, besarkan sikit. This represents the inclined section, the horizontal section, and then balik kepada inclined section, and finally pada horizontal section. This will represent kita punya loading on the staircase of the beam. Yeah, I mean loading on the staircase represented dalam kita punya idealized structure, which is our continuous beam. So kita akan ada W1, let's say this is W1, W1, W2, again W1, bebannya sama, the same ni, W1 katakan sini, and W2. So W1 L1 plus W2 L2 plus W1 L3 plus W2 L4, okay, would give us the F value. F would be W1 L1 plus W2 times L2 along the span of untuk W2. Then kemudian W1 times L3 and W2 times L4. And that will total up everything, will give us the value of F. Okay. So the same principle apply macam example number 2 saja. The same thing. Cuma we now deal with a bigger span, a thicker section, and a various loading W1 dengan W2 with different span for each W1 and W2. Yeah? Sama je. Unless kalau kita tambahkan ada pula beam kat sini, somewhere beam, and there is a beam somewhere here. Okay? When there is a beam somewhere there, maka the whole problem now becomes dua span. Dua rentang yang berbeza. We have two different span. L1 dengan L2. Okay. L1 dengan L2. And the design would now be separated kepada dua lah. We have yang warna merah ni, by adding this beam yang di tengah ni, the overall idealized structure for the staircase would look something like this. Okay. Where we will have kita punya support at ujung kanan, ujung kiri, left hand support, and somewhere dekat middle ni we have another support. And clearly our bending moment diagram would now be something like macam ni je lah. Yeah. Continuous beam, dua rentang. Span. Okay, so it depends on the location of the support, bilangan penyokong dia dan sebagainya. Then from there we will come up with our idealized section, and from there look at the loadings dan sebagainya. And the same principle applies throughout the solution for the example. Okay, so saya akan savekan ini. Right. Kalau tak ada soalan, we proceed kepada our third example. Example yang ketiga, yang mana dia? We'll now come to our third example. This is our second example. We'll move on kepada the third example, where now the third example is a totally different case compared kepada example 1 dengan example 3. 1 dengan 2. We're coming to example number 3, where now we have a staircase supported by landing. Bukan supported by beam, tetapi supported by landing. So the landing is now acting as a support for staircase. And how kita tengok ni, how is this example? How does it look like? Okay, we have a plan view and we have a cross-section view. So by taking into account these two views, pertama sekali, observation from this plan view, pertama sekali I would like to highlight that there is something particularly that we need to pay attention, ialah ada dotted line di sini. There is a dotted line sini and also a dotted line di sini. Okay, so when we look at anything yang ada dotted line macam ni, we know that this is a beam. Okay, this is one beam, and the beam, bila sampai this part is the landing part, bahagian landing. This is the landing portion of the staircase. Okay, and this is the beam at the end of the landing, maka if there is a dotted line di sini dengan sini, bermakna for this landing, kalau kita ambil cross section, okay, if I were to take a typical cross section of this landing in this direction, okay, in this direction, kena pula yang ni. Move this. Okay. If this is a typical cross section, maka what we see, it would be something macam ni. It would be, we have a landing. Okay. At the end of the landing, hujung landing ni, ada beam. Okay, ada beam. Saya indicatkan macam ni lah. Okay. There is a beam connected to the landing di hujung kiri dan di hujung kanan. There is a beam connected directly to the landing, okay, at both ends, pada kedua-dua hujung, sebelah kiri dengan sebelah kanan. Ni dia punya line diagram lah. This is the line diagram. Kita buat ni satu lagi line kat sini to show that this is the landing. Okay, so the landing tu ada beam on the left hand side dengan right hand side. This is the indication cross section, katakan cross section XX. Okay. So this is our XX punya cross section. We have two beams at the end of the landing, and because there is a dotted line di sini menunjukkan the beam and the landing is directly connected. So this landing can be idealized as a simply supported punya case. We have a landing, okay, and we have our support, hujung kiri dengan hujung kanan. And the shape of the bending moment would look something like macam ni lah. This would be the shape of the bending moment diagram, where this would be our maximum bending moment diagram, and this bending moment diagram can be obtained by FL over 8. Yeah? FL bagi 8. Simply supported case. This is the first time we are looking at a simply supported punya component. Previously, the first two example was continuous punya case. Now we are looking at something which is simply supported. We have beam at either ends of a landing, okay? And this is to show that the landing is being supported by beams to be, if we were to have a look at the dotted line, this tu menunjukkan there is a direct connection between the beam at both ends of the landing, okay, pada kedua-dua hujung landing ni, that is directly connected to the landing, making this particular beam, okay, beam yang di sini sebagai our support. Okay. So the beams yang di hujung sini dengan hujung sini, this is the beams that is supporting the staircase. Supporting the landing. Okay, itu focusing on the landing itself from this plan view. Now, if we were, saya savekan dulu. Kalau kita tengok pula pada dia punya cross section view, which is the lower diagram sini, clear? Okay. Kita dapati bahawa we will find out, from the sketch given, one thing is that there is clearly a gap between this landing dengan the beam at the end of the landing. There is a clear gap between these two components. Okay. There is a clear gap between the landing and the beam, which is at the end of the landing. So there is a beam, ada rasuk di sini, but then this beam is not functioning sebagai penyokong for the staircase because it is not connected kepada staircase. If this condition is such that we have landing, kemudian we have a beam that is directly connected kepada landing, then this is similar kepada example number 2. Okay. Beam at the end of the landing. Macam ni. Okay. But unfortunately, the beam dengan landing is not connected. There is a gap between the beam dengan landing, making it redundant. Bermakna this particular beam is not acting sebagai penyokong kepada staircase. So in other words, kalau tak ada beam ni pun tak apa. There is no function of this beam. If we were to remove this beam pun, it doesn't matter. It would not cause anything kepada tangga tu, because it is not supporting anything. Dia tak menyokong tangga. There is a gap between the landing dengan the beam. So it defeats the purpose. When there is a gap, then it means that we can say that the beam is not functioning as a support to support the staircase. So it might as well we can remove staircase yang this particular beam can be totally removed pun tak apa. It doesn't cause any harm to the staircase. Now from this schematic ataupun from this condition, okay, we will have a look from this condition. Now the schematic for this condition ialah we have staircase. Okay, I'm trying to figure out the schematic of this. Okay, we have a staircase, and clearly there is a support di sini because of this beam, this particular beam. There is a support over here, but then sebelah sini tak ada penyokong. There is no support di sebelah sini. Okay, on the right hand side ni, sebelah kanan ni, there is no particular support on the right hand side. So bermakna the staircase ni is handicapped. Yang ini ada support, we have a support on the left hand side, but there is no support on the right hand side. So what happens is lah, at the right hand side di sini, the landing is now behaving sebagai penyokong because there is no beam, ataupun this beam is not functioning as a support. Therefore, di sebelah kanan ni, at this particular portion, this landing, okay, landing yang ini is now supporting the staircase. Remember, landing ni sebenarnya ada beam. There is a beam. Right? There is a beam. Saya cuma tak dilukiskan di sinilah. There is actually a beam sampai sini. Okay, there is a beam ni. Ni ada beam. Okay. Tapi it's not shown dalam this typical cross section. Actually there is a beam. Beam yang ini yang saya maksudkan, the beam that I'm referring to is beam yang ini. Okay. Kalau tengok pada plan view, the beam yang ini. This beam, okay, this particular beam, dan juga this particular beam. Kalau cross section dia is something like this. This is the beam. Okay. So this beam is now supporting the landing. So the landing will now support the staircase. So bermakna at this end ni, hujung di sini, we have the landing which is about 1.5. Maka, okay, this total landing punya span ataupun lebar landing ni is approximately 1.5. Daripada sini sampailah sini is approximately 1.5, 1500. Center line dia, okay, center line of this 1.5 meter will now be kita punya support. Okay. Center line sini, somewhere di sini. This will now represent the support di sini. Untuk this staircase. So the green support di sini ialah sebenarnya coming from the staircase. Coming from the landing. Landing is now acting as penyokong kepada tangga. Landing is supporting the staircase because the beam at the right hand side ni is not connected kepada landing. Therefore the beam at the right hand side sebelah sini is not functioning as support. Therefore this staircase yang warna biru ni is now handicapped. Ada one beam sebelah sini, left hand side, but right hand side tak ada beam. So the right hand side sebenarnya is being supported by the landing, and this can be clearly seen. Saya save dulu. Okay. This can be clearly seen from the plan view. Okay, so this staircase, this landing is now supporting this staircase dan this staircase juga at this end. Sebelah sini ada beam, sebelah sini tak ada beam. So this landing now is being the support, behaving as a support for the staircase. Okay, so once this landing is acting as support, bermakna the reaction coming from beam ni, from the staircase, there will be a reaction. Okay, tindak balas ya. This reaction will now be transferred kepada landing. This reaction in red ni is the reaction coming from larian yang ini, from this flight of staircase dan from this flight of staircase. Satu going up, satu coming down. Ya. Yang ni katakan daripada bawah naik atas sampai landing. Ini from landing naik ke atas lagi. Okay. So the reaction coming from the staircase will now be transferred kepada landing because landing is now supporting the beam, supporting the staircase. Landing menyokong tangga. Landing menyokong. This is the case where we have not the beam acting sebagai penyokong, tetapi a different component. In this case, it is a landing. It is a landing. It can be another staircase, supporting another staircase pun boleh juga. We'll come to that later on. But in this particular example, is where the landing is supporting the staircase. The landing can support the staircase because the landing itself has two independent support. Remember the sketch yang kita tengok tadi, the cross section. So the landing has dua penyokong. We have a beam supporting the landing, which is this beam dengan this beam. So the landing is complete lah, is perfect lah. Bermakna it is a case where the landing, okay, this is the landing, and we have a beam support at both ends. Sini ada beam, sini ada beam. Okay, so the landing is now behaving as the main component, and it is to be designed as a simply supported case because from what we see, there is no continuity on the right hand side dan juga on the left hand side. So the landing itself will be a simply supported component, but on the landing itself, atau pada landing tu, pertama sekali we will have the GK dengan QK of the landing, and jangan lupa the GK dengan QK ataupun the reaction coming from the staircase. So ada dua komponen acting pada landing. One is the GK and QK acting on the landing itself, because landing tu it has GK dengan QK juga. Okay. And the second thing is that there is a reaction from the staircase yang ini that is being transferred to the landing, because landing is supporting the staircase. Okay. Ni landing supporting the staircase. So when the landing is supporting the staircase, bermakna the reaction from the staircase has to be transferred kepada landing. Has to be transferred to the landing. Yeah? Before the landing can be designed. So now we need, because kita ada one component supporting another component, okay, landing supporting a staircase, maka dengan sendirinya we need to have two separate design. One design for the staircase, satu lagi design for the landing. Okay. For the staircase punya design is similar kepada example number 2, quite similar kepada example number 2. For the landing punya design is where we consider loading coming from the self weight of the component, okay, self weight of the landing, which is in blue, and yang warna merah ni is the reaction coming from the staircase that the landing is supporting. So we need to design dua benda. Satu the inclined section, which is the staircase. Satu lagi the horizontal section, which is the landing, because the landing is supporting staircase. Ada komponen utama menyokong secondary component. The main component is the landing. The secondary component is the staircase. So we need to separate the design antara dua ni. This is what happens dalam example number 3. Okay. Anybody tak berapa clear on how kita come to a conclusion that now we are looking at a case where we have two different components. One is the landing and another one is the staircase, the inclined component. However, these two components are is not considered as one component, tapi dua separate component, because landing dengan tangga, landing is now supporting the staircase. Kalau example number 2, the landing dan juga the inclined section design sekali, because landing tu dengan tangga it is not separated, dan juga we have a beam at the end of the landing yang bertindak sebagai penyokong. In this case, however, this particular beam at the end of the landing is not connected kepada landing, so it cannot behave sebagai penyokong. Pertama, bila there is no support pada right hand side ni, maka this staircase ni, tangga ni, has only one support di sini. Ada hanya satu penyokong sini. Sebelah sini, sebelah kanan ni, there is no support. So bermakna in this case, it automatically ia menjadi satu dependent, bergantung kepada yang lain. It becomes automatically a component that will need to depend on another component because it only has one support sahaja. Okay. Any component yang ada dua support, then it doesn't need to depend pada mana-mana because it already has two support. But any component which has only one support, then on the right hand side ni, it depends on something else. It has to depend on something else as penyokong, because only one support di sini. Clearly only one support. And on the right hand side ni, from the plan view, okay, indicationnya ialah we have a beam, okay, on either side of the landing. Okay, sebelah kiri dengan sebelah kanan landing. This is our landing, sebelah sini. So on either side of the landing there is a beam, and the dotted line indicates that there's a connection, a direct connection between the landing dengan beam. Contohnya, this is our landing, this will be our beam, macam tu. So this represents a direct connection, okay, a direct connection between landing dengan beam, because kita ada dotted line sini. And this is pada kedua-dua position, at both position. Okay, so the landing is now being supported by beams. Clearly, ada dua rasuk menyokong landing. So landing when there are two beams ataupun two supports to a component ni ada penyokong sebelah kiri dengan sebelah kanan, then it becomes the main component. Any component that has two support menjadi yang utama. Tangga has one support, it depends on something else, and that is why we come to a conclusion yang kita katakan that the staircase di sini, staircase yang ini has only one support, maka it will depend on the landing sebagai the second another support for the staircase. So itu yang kita conclude that in this example we have a case where the staircase is being supported by beam on one side and landing on the other side. Sebelahnya ada beam penyokong rasuk, sebelah lagi pelantar ataupun landing which is now acting sebagai support kepada tangga. And the landing itself has two independent support, making it satu komponen yang utama yang boleh menanggung, that has the capacity to support others. Okay, the main has two support and it has the capacity to support the staircase. So bermakna that is how we come to the conclusion yang the landing now is now the main support for this staircase on one side, pada satu hujung. Okay, pada hujung sebelah sini, now this landing is now acting sebagai penyokong untuk tangga di sini dan penyokong untuk tangga sini at this location. Okay. So itu yang we can come up with this rumus ataupun conclusion. Okay. Rumusan, conclusion from this example, from this sketch given. So from the sketch given, clearly we need to design dua elemen secara separately because kita ada, imagine lah, kita ada rasuk utama and we have a secondary beam. So we cannot design the main beam dengan secondary beam as a single design, tak boleh. Okay, so we need to design the main beam separately, we need to design the secondary beam separately. The main beam is supporting the secondary beam, which means that the load on the secondary beam will then be transferred kepada main beam. The same principle applies. Reaction from this staircase will then be transferred kepada this how many minute? 4 minit to the landing, and then barulah landing tu boleh direka bentuk. Okay, so then this is the direction ataupun solution for example number 2. Yeah. Any question yang tak apa jelas?
Doktor, yang support daripada landing tu dia punya location dekat tengah-tengah landing
Support location untuk, yes. Okay, remember kita punya support, center line support tu merupakan dia punya span. Bermakna for this staircase ni, as for this landing, center line sini dengan center line sini is the span in this direction. Bermakna from this center line kepada this center line, yang ini adalah L span untuk landing. Untuk landing, untuk pelantar. Manakala the span for the staircase is from center of this beam, okay, center rasuk sini, sehingga center of landing. Ini adalah span for staircase, for the inclined staircase. Staircase lah saya tulis ni, staircase. S-T-A-I-R. C-A-S-E. So ada dua span. Okay, and at right angles to each other, orthogonal to each other. So kita ada dua span. One span is to represent the staircase punya span, which is from the center line, okay, center line of support, because tangga ni is now the support for the staircase. So kita ambil from center line lah. This is to represent center line lah. Yeah. Ini 750. 750. Ini center line. Okay. This is the center line untuk support sebelah kanan for the staircase. For the staircase. Support sebelah kiri, center line di sini lah. For the staircase. Okay. Support for the landing, because landing has two beams kat sini, dua rasuk, which is supporting the landing. We have two beams di sini. Okay. So these two beams ni, dua rasuk ni, is now supporting the landing. Therefore, from center of the beam sebelah kiri dengan sebelah kanan, this green line represent span untuk landing. So we have two components lah, separate components. Kita tak boleh nak design serentak. Okay, because one component is supporting another component. Seolah-olah the green one is the main beam, the red one is your secondary beam. Staircase tu menjadi secondary beam, pelantar menjadi primary beam. Rasuk utama, rasuk kedua. So to design ni tak boleh nak design serentak. We have to design separately. Okay, one design for beam, main beam, another design for secondary beam. Tapi remember to design the main beam, because the main beam is supporting the secondary beam, maka direction from the secondary beam kepada main beam has to be considered. Bermakna when we are designing the landing nanti, because landing ni penyokong pada tangga, therefore the loading, the reaction coming from this staircase has to be transferred to the landing before landing can be designed. Sebelum landing boleh direka bentuk, sebelum rasuk utama boleh direka bentuk, we need to consider the loading coming from the secondary beam, ataupun in this case from the secondary staircase. The primary component is the landing. The secondary component will be the staircase. Okay, Azanita, tak apa. Kita break sekejap, okay? And kita jumpa balik. We take 5 minutes break, okay? And then kita akan discuss lagi sekali.